Gökçe Hocam stated that before we already talked about the architectural fire and life safety design, but today we will have a quick review on architectural design, and we will focus on the mechanical design effect and their consequences on the architectural design criteria, and we will understand how we coordinate, how we manage the mechanical designer during our projects as we are working as a project coordinator. And as you know, the architects are allocated for the coordination of the project. The architects are managing and coordinating the mechanical and electrical design, and they are integrating their last design onto the project. That's why I think all of the architects should know about should have a minimum knowledge of mechanical and electrical design criteria to achieve the project as required. Otherwise, at the end of the project, we are facing always with some problems due to the bad misunderstanding of other disciplines to each other. Before starting, as Gökçe Hocam today, by this opportunity, we are sending our gratitude to Atatürk, founder of our republic. This 10 November, we lost him, but we are following his ideas, and we are trying to act as he described us during the foundation of our republic. First of all, after our last session, the fire code, the Turkish fire code is revised, and the latest version is submitted, the 2021. There is no lot of huge changements, huge revisions, but we only have some new additional clauses regarding the wildfire. As you know, the last summer and before, we had some huge wildfires, and we lost a lot of forest areas in Turkey. That's why we added some new clauses regarding the wildfire precautions, and also we have some new clauses regarding the design of the enclosed car park for the cars working with liquid petrol gas LPG. These are the only revisions. The rest of the code is staying as it was. And also, you know, we have always NFPA 101 and NFPA 5000 for the architectural and structural design during our projects. I would like to have a quick review because you are not always working with the fire and life safety design. I think it would be better to have a reminder about the definitions and the main design criteria, and then we will focus on the mechanical system effects on the architectural design criteria. As you know, in Turkish fire code, we have two descriptions of the height, building height and construction height. One of them is including the basement floor, and the other one is measured from the ground level. The building height is measured from the ground level to the roof level, and the construction height is also including the height of the basement floors. And then we are deciding whether the building is high-rise or not, and the design criteria is totally changing depending on the height of the building. We have some limitations about the building height and construction height. And when we define the height of the building, we will start to understand which systems are mandatory and how we should continue our design. And that's why these definitions are always important for the architectural design. This is the schematic description of the high-rise building. As written here, if the building height exceeds 21.5 meter, or it can happen on the same time, or it can be separately. If the construction height is exceeding 30.5 meter, we are considering this building as a high-rise. From mechanical point of view, what is required for the high-rise? We should focus on them because these systems become mandatory if the building is high-rise. But I would like to emphasize that not the building height is only input to decide whether these systems are mandatory or not. Even if the building is not high-rise, maybe we need to provide these systems such as sprinkler system or landing valve system to get these advantages on the architectural design. I will explain you how in the following slides, but first I would like to emphasize this before starting the main part of the presentation. But for the high-rise building, for the residential building, if the construction height exceeds 51.5 meters, or for the non-residential building, the construction height exceeds 30.5 meters, the automatic sprinkler system becomes mandatory. And informing the mechanical designer is the responsibility of the architecture regarding construction heights. That's why you need to know that, for example, some of the investors of residential buildings are limiting the construction heights at 51 meters, not to provide a sprinkler system. They are limiting their height to make to cut the expenses during the construction phase. That's why the architects should ask the investor whether they have knowledge about the sprinkler or landing valve system mandatories regarding the fire code or not, and then you decide the exact construction height during your project. And for the hotel and dormitory, it's a little bit different. They are separated from the rest of the building. If the construction height exceeds 21.5 meters, the sprinkler system becomes mandatory as per Turkish fire code. And the landing valve system becomes mandatory for the high-rise building. It's combined with the sprinkler system. For this combined system, we are calling them water-based suppression systems altogether: the sprinkler system, landing valve system, and also the fire hose cabinets. But we will see how it will change our architectural design when we provide these systems. From the mechanical point of view, but the smoke, it is the smoke issue. The pressurization systems become mandatory if the construction height exceeds 51.5 meters, or even if our building is not exceeding 51.5 meters, if the stairwell height exceeds 30.5 meters, or if the stairwell serves more than 4 basement floor, the pressurization system becomes mandatory as per Turkish fire code. The international standards are a little bit different from our local code. For example, regarding the NFPA, the limitation is 23 for the pressurization of the staircases, and they are limiting the number of basement floor with only one floor. For example, if you are responsible for the international project and you have 2 basement floors, the pressurization systems become mandatory as per international building code or as per NFPA. That's why from the beginning of the project, it would be better to decide the main reference code to understand what we need to provide for this specific building. And also for the building where the construction height exceeds 51.5 meters, we need to provide fire service access elevators separate from the circulation elevators. It is dedicated for the usage of the fire brigade during a fire incident. And it also should be pressurized by a positive pressurization fan. And also for the high-rise building, if the construction height exceeds 51.5 meters, we also need to provide a corridor smoke exhaust system, and it requires a great coordination with the architectural team and the mechanical team to find some vertical shafts, because for each corridor we need to provide 1 exhaust shaft and at least 2 separate makeup shafts. I will explain with all details. it's very important if we are not coordinating it at the beginning of the project, and if we finalize the structural design, it becomes really impossible to find required area of shafts for this corridor smoke exhaust system. It's also the responsibility of the architect coordinate these shafts and the shaft locations on a high-rise building, within the high-rise building. And also for the hotel and dormitory buildings, it's a little bit different. Even if the building is not a high-rise, even if you have a only 2 or 3 story building, but if the building sectional area is large, it means if you have some long corridors more than 45 meters, you should either provide sectional zone doors, smoke-proof doors, or you need to provide corridor smoke exhaust system. It's also decided by the architect. If the architect is okay with providing a door for each 45 meters, then you are allowed to omit smoke exhaust system. But normally these doors are not preferred by the architects due to the decorative issues. That's why in most of the hotel buildings, we have corridor smoke exhaust system as well. And also, this is a very important issue. This is specific to Turkish fire code. If we don't have a 100 centimeter height parapet, 2-hour fire rated parapet on the facade between the floors, the Turkish fire code requires a closely located sprinkler heads for the facade protection. For the curtain walls, in Turkish it's called giydirme cephe. If you have glazing facade for your building, it is really hard to provide these 1 centimeter spandrel panels on the facade because it's really affect negatively the outer look of your building. That's why if you are not providing 100 centimeters of parapet between each floor, you need to inform the mechanical designer to process their design to have a closely located facade protection sprinklers. Otherwise, when you finalize the project and when you are trying to hand over to the owner during the I don't know the exact name, ruhsat phase, when you are trying to get the permit for your building, when the local fire brigade comes and if they see that there is no parapet, they are directly requiring the closely located facade protection sprinkler. It may postpone the opening of your building. They are really strict for this issue. That's why it is also your responsibility as an architect to decide whether a parapet you will have or you need to inform the mechanical designer accordingly. When we review and when we try to remember the travel distances measurement, as you know, the red ones are the common path of travel because we don't have any alternative exit access route. And the red, the green ones are the travel distances. It means we have at least 2 alternatives to escape. When we have sprinkler system and when we don't have, these distances are totally different from each other. We will see on the plan. It is also a reminder for the travel distances and the measurement of the travel distances. It is very stringent. As per Turkish fire code and also as per international standard, especially the dead-end corridor and the common path of travel become very stringent if you don't have sprinkler system. As I said from the beginning of the presentation, even if the building is not high-rise, even if the building is not required to be sprinkler protected due to the construction height or building height, you may require sprinkler system to make this design more efficient. Otherwise, you need to provide additional staircases or you need to make some small corridors instead of long corridors, and it affects negatively the efficiency of your architectural design. That's why in most of our projects, even if it is not mandatory according to the building height, the sprinkler system is provided because of the requirement of architect to use this additional common path of travel and dead end corridor lengths. For example, here, if we are comparing the storage occupancy situation, just let me annotate it. We have two columns on this table. The right one is given is for the building protected by sprinkler system, and the left one is for the building that are not protected by a sprinkler system. As you see, the common path of travel is 25 for the sprinkler building, but only 15 for the non-sprinkler building. If I come to the previous, if I come to the previous slide, you can see that these yellow ones is become 25 for the sprinkler building. But if we don't have a sprinkler protection within the building, it's only 15 meters. It's very limiting design criteria. That's the same for the dead end corridor length. For example, for the dead end corridor, it is 20 meters for the sprinkler building, and it's only 15 meters for the non-sprinkler building. And for the common path of travel, we already talked the common path of travel, the dead end distance, and also for the travel distances, it becomes 45 from 60. It's very challenging if you have only if you have only two staircases, and if you don't have a sprinkler system, probably you need to provide an additional third staircase for your building, for example, here. Sorry. For example, if you don't have a sprinkler system, you probably need to provide a third staircase in the middle of your building to fulfill the travel distance requirement of the Turkish Fire Code. Instead of providing additional staircases or instead of making some structural and architectural revisions, you are allowed to provide a sprinkler system and execute your design accordingly. Most of the architects prefer it because the revision of structural design and the revision of architectural design according to the non-sprinkler building requirements is generally more expensive and more hard than providing a sprinkler system. That's why you need to know that, and you keep it in your pocket as a second alternative. If you have some troubles regarding the architectural and structural design, as an architect, you have always chance to inform and you have always chance to require the investor to provide a sprinkler system to have a more efficient and to have a more flexible design in your building. That's why it's important for me to learn to teach, to give this information to the architects as you, because you will be responsible for the huge project as well. And also the travel distances. I had this slide from the last lesson, the measurement of the common path of travel distances. You already know them, but I put these slides as a reminder on my presentation. And as you know, the number of exits are not changing with the mechanical proportions, but the location and the remoteness criteria of the separate exits, alternative exits, by changing according to the existence of the fire sprinkler system. I'm passing this one. For example, here you have a storage area. The area is less than 1,500 square meters, and the number of people is less than 50. It's okay if we fulfill the common path of travel distances. But when we exceed the 50 people, as you remember, we need at least two remotely located escape door. That's why we provide a second door. But the distance between the door is also important for the remoteness criteria. It should be not less than the half of the diagonal distance of the subject room or subject building. But this half rule, the one of two rule, is only applicable for the non-sprinkler building. If you have a sprinkler protection, the rule becomes more flexible, and you are allowed to provide only 1/3 diagonal distance, and it gives you the chance to make these doors more closer to each other. In some situations, for example, when you are designing a shopping mall, you can only provide these remote alternatively located doors on the facade of the subject unit, and the facade is really limited. In shopping malls, you have a facade and you have very long width through the service corridors. That's why having a sprinkler systems give you the chance to make these remotely located doors close to each other. If you don't have a sprinkler system, the design may be locked. Maybe you cannot be able to execute the process design due to the lack of area, due to the lack of facade to provide these additional doors. That's why it's important to know the advantages of the sprinkler system during sprinkler system on the remoteness criteria as well. And also, it directly affects the locations of the staircase as well. As you know, the remoteness criteria is also applicable, is also required for the locations of the staircase as well. The distance between the staircase shall not be less than the half of the longest diagonal distance of the total building. When you have a sprinkler system, it's also becoming 1/3 of the diagonal system, diagonal distance as well, and it gives you a chance to have a smaller building core. As you know, the core efficiency is really important for today's design. If you have a big and large cores, it means you have less rentable area and you have less sellable area, and it would not make the investor happy. All of the designers, all of the architects for today's construction work are trying to make these building cores as small as possible. That's why to have a sprinkler system gives you a chance to design smaller corridors and also the smaller building core, and it will have a positive effect on the efficiency of your building design. That's why we are always preferring to have a sprinkler system and taking their advantages on the remoteness criteria. Also, as we talked before during the architectural lesson, the half of the staircase shall discharge directly to the outside of the building, and the other half is allowed to discharge on the lobby or the ground floor. If you have a sprinkler system, the distance between the discharge point of this staircase and the discharge door to the outside of the building is allowed to be 15 meters. But if you don't have a sprinkler system for your building, it is limited to 10 meters, and it's very challenging. To fulfill the 10-meter requirement, you need to locate your staircase at nearest point to the facade. And as architect, you not like to see a staircase core just next to the facade because it's not looking really good. We always prefer to have these staircase on the core area of the building. That's why having a sprinkler system will give you also flexibility to get your staircase core at the center of the building, and it's also have a positive effect on the area that you lose because of the core of your building. Okay, and now I would like to explain you which point as architect which points you need to take into account during the design of your building to make it fully compliant with Turkish fire code and also the international codes. Even if the mechanical design is executed and is followed by the mechanical designer, as architect, you need to check whether their requirements or whether their design criteria are going parallel to your architectural design. Otherwise, the coordination between the architectural, structural design and the MEP. MEP design means mechanical and electrical and plumbing. They are calling it MEP on site. The MEP design, the coordination between MEP and architectural becomes more difficult to you if you if you emphasize the inconvenient requirements of the MEP designer at the end of the project. That's why when we start the project, first of all, we are trying to review and check the shaft locations, main mechanical and electrical room locations, and also the location of the combined water-based suppression system riser, etc. And it gives us it makes our design very easy to be executed because it's already solved, it's already placed, all the shafts, main electrical rooms, and then we can use the rest of the area as we require for our architectural point of view. That's why the things that I will explain you from now on, it's very important for architects to understand and to solve before beginning before start to develop the design in your projects. First of all, if you have a sprinkler system, if you have a water-based suppression system in your building, the fire pump room is the heart of this precaution. We need to design and we need to locate this very, we need to give attention to the location of this room because it's the heart of the system. If the pump does not work, or if we have some problem to reach the fire pump room, the rest of the system will not work, and all of the design will go to rubbish because of our faults. The fire pump room shall be 2-hour fire rated separate zone. First of all, that's why we need to design their perimeter walls accordingly. They should be at least 20 centimeter block walls to fulfill this fire rating requirement. And also the most important thing, the fire pump room shall be just next to the fire tanks. If we have separate fire water tanks, reservoir, and fire pump room, it's really difficult to get this water on the fire pump room. Some of the architects are requiring this due to the lack of area within the building, but it's not a correct design. We always keep the water tanks just next to the fire pump room so that we have these pumps in connection with the water, and we can keep the system convenient all the time. And the third one, but I think it's the most important one, the fire pump room shall have direct access to a staircase. Most of the architects are not understanding the main reason of this requirement, but the fire pump room shall be kept accessible in case of fire in the building. It means even if we have a huge fire, even if we have a large fire incident within the building, we need to reach the fire pump room to check whether they are working as required, or maybe we need to start manually these fire pumps. That's why even if the building is burning, I'm exaggerating, even if the half of the building is burning, we need to access this fire pump room. And the only way to access these fire pump rooms by not affecting the fire incident within the building is to have a direct connection between the fire pump room and the staircase. That's why we are always checking at the beginning of the project whether we have a direct connection to the staircase without passing other areas such as car parks or any other office area or residential area. This is also important. At the first stage of the project, you need to decide the location of the water tanks, and just next to the water tanks, there should be a fire pump room, which is directly connecting the staircase. And then you give this location to the MEP designer, mechanical designer, and they check whether the fire pump room area is adequate to put the fire pumps in. And also they will check the capacity of the water tanks. If they are not happy with them, they can inform you and it can be revised. But the first thing is the location is decided by the architect and then given to the mechanical designer. And also this is also very important design criteria for the architects regarding the mechanical requirements. As per Turkish fire codes, we need to have separate vertical pressure zones for the water-based suppression system because we have some limitations, both minimum and maximum limitations for the system pressure limitations. For example, at the highest point, we need to have at least 4 bar of water pressure. And also at the lower point of this vertical pressure zone, the maximum pressure is limited to 12 bars. That's why for each 45 meters, we need to have a separate vertical pressure zone. It is also the same for the daily usage system. For example, heating and cooling system, we also have some vertical pressure zoning. But today I'm just explaining you the from fire point of view. That's why if you have more than 3 vertical pressure zones, it means your building is higher than 135 meters. You need to provide an additional intermediate technical floor on your building. For example, this is a project from Uzbekistan. The building is more than 200 meters. That's why after having 3 vertical pressure zones, we provided an intermediate level of pump, and the upper levels are feeding by this intermediate level of fire pump. If you are not taking this detail during your design, take into account during your design, the mechanical designer comes into the mechanical designer comes into the project. They will ask you to allocate an intermediate floor, for example, 20th floor or 21st floor for the mechanical systems, and it will cause you some problem because you are always thinking that this level also will be used as a social area or will be used as residential or what is this, as a business unit. And then you will lose a whole floor by the requirements of the mechanical designer. But if you have some knowledge about the vertical pressure zoning, and if you have knowledge what is the limitation for having an intermediate level of mechanical floor, you will take this into account from the beginning of the project, and you will develop your design accordingly. And you are not facing any problem during your design phase. It means when you exceeding 135 meters in your building, you need to think that you need to take into account that you will have an intermediate level of mechanical floor, and one of the floor, according to the area of your sectional area of your building, will be allocated for the mechanical system. And also structural engineer should take this into account because in this floor you will have water tanks as well. Having a water tank on the upper floors is really difficult from a structural design. The structural design and the beams and the columns of this floor shall be designed accordingly to have an adequate load-bearing feature. Otherwise, you may not able to provide you may not able to locate these water tanks on this floor. That's why all of these together should be coordinated by the architect from the beginning of the project. And also, when we have water waste suppression system, when we have sprinkler and landing valve and fire hose, we should have risers within the staircases. Most of the architects are requiring to locate these risers on the mechanical shafts, but it is not convenient. As per Turkish fire code and also as per international standards, these landing valves and also these risers means the main pipeline taking the water to the upper levels. You can see there, this is a pipeline passing through the landing of the fire escape stairs. It should be understood that these riser landing valve and also the valve group which is provided for each of the floor shall be located within the staircase. We are not allowed to locate them within the mechanical shafts, or these gate valves are always requiring by architects to be located within the suspended ceiling. For example, we have an office floor, we have a suspended ceiling here. They are requiring to provide these equipment here and with a cover reaching to the gate group. It is not allowed because during a fire incident, both the technical team of the building and also the fire brigade should reach the landing valve, should reach the valve groove of the sprinkler system easily without affecting by the fire, as we explained for the fire pump group. The landing valve, the floor gate valve group should always be accessible during a fire incident. That's why we need to locate it within the fire escape staircases. But the location is also important. According to the clear width of your staircase, there will be a stair circle here. You need to draw it on your plans, and all of the equipment, both the riser, the landing valve, and if you have a drainage pipeline, should be located at outer areas from this staircase semicircle. Because these areas should be used by the people they are escaping from fire, and these dead areas can be used for the sprinkler system equipment to be located. It means on the red areas we are not allowed to locate sprinkler system equipment, but for within these red areas we can locate our riser, our landing valve, and also the gate valve group. Just for your information, these landing valves, sorry, I will check the next slide whether these landing valves, when we see the section, for example, this is one floor and this is the other floor of the staircase, the riser going through the upper floors. These landing valves are located about 80 centimeters to 120 centimeters from the floor level. But these gate valve groups are located near to the ceiling. They are located there. We have a gate valve here, and we have flow switch and pressure gauge. And the system is entering to the floor by the staircase, but they are located nearest to the ceiling. That's why the location of the landing valves is really important. They should be checked whether they are encroaching the staircase circle. But for the gate valve group, you are more free. You have more flexibility because it's located nearest to the ceiling. And if you have some equipment above 2.1 meter, it is the minimum headroom according to the Turkish fire code. The location is not important because that's not causing us any obstruction during the egress, during the escape of the people. That's why This is also important, and it's also it should also be coordinated by the architect, and it should be coordinated with the mechanical designer. Because, for example, in high-rise buildings, generally all of the doors are located on the same side. For example, we have, sorry for my bad drawing. So we have a door here, and the riser always located there. But in some floor, maybe the location of the entrance door of the staircases may be required to be on that side. In this situation, you have to inform the mechanical designer so that he will revise the location of the riser, and he should relocate the riser location. When we see it on the section, sorry, for example, the riser comes from this edge, but due to the location of the staircase door, they may relocate the riser and continue like that. Because, for example, that should be the 20th floor, and this one is 21. For one, we have a door here, and for the lower, we have a door here. We need to explain these changements to the MEP designer so that they will relocate, they will change the direction of the riser pipeline, not to block the entrance door to the staircase. It's also the responsibility of architecture as a coordinator of the project. And also, if you have a fire service access elevator, as I described below, before, the service access elevators are allocated, are given to the fire brigade so that they can go upper floor quickly, and they can interfere the fire quickly. Generally, they come to the lower level of the fire. They come to the just one or two beneath floor, and then within the fire protection lobby, they make their preparation. They prepare their equipment. They prepare their clothes, and then by the fire escape stair, they go to the upper floor and interfere the fire. That's why it's important to have landing valve system just next to the fire escapes, just next stair, neighboring the fire service access elevators, because the fire brigades are coming with these fire service access elevators. They are preparing within the fire protection lobby, and then they enter to the fire escape stairs for going upper floors, and they are using the landing valve and the riser located within the fire escape stair. It means if you have two separate staircases, the location of the landing valve is recommended to be provided within the staircase neighboring the fire service access elevator. It's really important for us. Otherwise, they need to change location. For example, just let me clear. For example, if you locate the landing valve for this staircase, first of all, they come with this elevators. They will prepare here, and they will take all of the equipment. They will go to the other stair, and then they are going to upper floor to use the landing valve system, and it will cause loss of time for the intervention to the fire. And that's why it's always better to have a clear design. It's better to have an optimum design, and that's why we are always providing the landing valve to this staircase. It's not taken into account by MEP designers. They are always trying to locate the risers on the nearest staircase, but as an architect, you need to inform that you are requiring this riser and landing valve into the neighboring staircase to the fire service access elevator. And also, sorry. Also, for the latest projects, we are always finding these open grid ceilings, laminated and baffle ceilings. within the project, and architects are not preferring to see the sprinkler head beneath this decorative ceiling. We have some rules. We have some rules to omit these lower level sprinkler heads while designing this kind of open grid or laminated baffle ceilings. Architects should also know that, because if you are the level of the suspended ceiling affects the requirement of the sprinkler beneath the suspended ceiling or not. For example, you have a ceiling here. It's the concrete ceiling. And then you have a decorative laminated suspended ceiling here. We have three different rules. First of all, the openness of this ceiling should be more than 70%. The first rule is that you need to select the material of your suspended ceiling accordingly. Otherwise, you will have a sprinkler on the ceiling, on the roof ceiling level, and also you need to provide the sprinkler beneath the suspended ceiling as well. This is the first rule, the openness criteria, and also the distance between the ceiling and the suspended ceiling shall be not less than 60 centimeters. You need to decide the level of your open grid ceiling accordingly. Otherwise, you always need two levels of sprinkler heads. And if you are fulfilling both of the requirements, and if you are fulfilling the open grid ceiling physical requirements, and I will explain you, the distance between the laminated baffles shall be not less than the depth of the grid ceiling. It is the issue about the water to be reached beneath the ceiling. If you have very high profiles, then the water will not reach to the floor level, and the fire will not be taken under control. That's why you need to check the physical conditions of your ceiling, and you need to check the openness, and also you need to decide the levels of the suspended ceiling so that the lower level sprinkler can be omitted and you can find a view that is required by architect point of view. Otherwise, you will have a sprinkler beneath of the open grid ceiling, and it does not look really good when you compare with the decorative objects, alternative decorative objects. That's why this is also the responsibility of the architect to design open grid ceiling and coordinate it with the sprinkler head requirements. And also, generally, the sprinkler heads are white colored, but according to the ceiling or suspended ceiling color, architectures may require different colors of sprinkler heads for decorative issues. Just be informed that painting of sprinklers are not allowed. If you paint a sprinkler by a spray painting or any other type of painting, since it will not be activated as required, the sprinkler shall be removed and shall be renewed by a new one. If you, as architect, if you'd like to have some colored sprinklers, for example, black or silver or any other yellow, you need to inform the manufacturer. They will paint the sprinkler head at factory, and then it is allowed. But the manufacturer shall be informed from the beginning of the project, because it takes time to manufacture sprinkler heads with different RAL codes. But it is possible. If you know that, you will define the sprinklers, you will define the colors for separate areas, and you can procure these sprinkler heads with different colors, and you will achieve your design. Otherwise, if you require the painters to paint the sprinklers on site, when the fire check is come, they will require to renew this sprinkler heads, and all of these sprinklers will go to the rubbish, and it will cause loss of money and also loss of time due to the waiting for the brand new sprinkler heads. And also, architects are always requiring to put the fire hose cabinets back at the back of the cover, decorative cover. It is allowed, but we have some requirements as well. In case of fire, the first intervention, the first interfere is done with the fire hose by the users of this office or residential area. That's why we need to find the fire hose cabinets easily. They should be found. They should be distinguished easily. That's why if you have cover, if you have decorative cover for your fire hose cabinets, then the ANFPA requires this kind of stickers, this kind of signboards on the top of the decorative cover to emphasize the location of the fire hose cabinets and also the fire extinguisher. We don't have a specific color description for this signboard, but the only thing is to have a contrast color. For example, for this kind of decorative laminated covers, it can be red, or it can be green, or it can be blue. The only thing is to make people to understand the exact location of the fire hose cabinets. And then it helps your interior design, it helps your fit-out design, and it gives you more flexibility to choose covering material for the fire hose cabinets as well. And also it's important thing, because it's always conducting in a wrong way on the construction sites. Should be know that embedded fire hose cabinets are not allowed for the fire rated walls, because when you provide any embedded equipment on the fire rated wall, the fire rating becomes the fire rating of the wall becomes how can I say, this wall is not anymore fire rated, because you have
unacceptable.
You have an unprotected opening on your wall, because the steel sheet of your fire hose is not providing you the fire rating. It's only providing you the integrity of the wall. That's why, as an architect, if you are requiring embedded fire hose cabinets instead of mounting on the wall, you need to provide a rated wall with a niche, so that you can install your fire hose cabinets within this niche without adversely affecting the fire rating of the rated wall of a compartmentation. It's really important, and when we determine this kind of inconvenience on the floor, we always requiring to provide additional masonry at the back of the fire hose cabinets, and it's really expensive and it's really hard to construct this wall when you finish the construction of the mechanical shafts. That's why it should be coordinated before finalizing the structural design and the architectural design of the floor. And also we have a corridor smoke exhaust system, and as architects we need to make attention to some points during the design. The general principle is to exhaust smoke from the fire floor and give fresh air to the neighboring floor, so that the smoke will be kept within the fire floor and it will be extracted by the ducts and it will be thrown to the outside of the building, so that the smoke will not propagate to the neighboring areas and to the neighboring floors. That's why it's important. This is the main principle. And also, in order to make some extraction from a floor, we need to give at least 30% of fresh air so that we can extract an air from the fire floor. Otherwise, the floor will become to the negative pressure and it will be vacuumed, and the extraction may not be possible without giving a fresh air. And also the locations of the fresh air shafts and fresh air grills and the location of the exhaust grill is really important, because you are trying to keep the exit access clear of smoke. That's why we are always locating the makeup grills just next to the staircase. I will make it by blue. We provide fresh air just next to the staircases. And we always locate the exhaust shafts as far as possible from the staircases, so that when we have a fire, the air movement will be like that. From fresh air, the air will become from fresh air shaft, and they will go through the exhaust shaft. They will come from fresh air shaft, and they will go to the exhaust shaft, so that we will accumulate the smoke far from the staircases, and the entrance of the staircases will always be kept smoke-free. This will give us two advantages. First of all, the people who are living in this floor may easily find the staircase. They may see the staircase, they see their route, they see their path. And also when the fire brigade comes to the floor by staircases, this one or this one, when they go out from the staircases, they have a clear area so that they can know where the fire is. If you have smoke accumulation just in the entrance of the staircases, neither the living people on this floor can easily find the staircases, and nor the fire brigade coming to the floor can easily distinguish the location of the fire. That's why the locations of the smoke exhaust shaft and the makeup air shafts are very important. And the shaft locations are approved by the architect. Even if the mechanical designers send you wrong shaft locations, you need to inform the exhaust shafts shall be as far as possible from the fire escape stairs, and the makeup shafts, makeup grills should be located just next to the staircase. This is the responsibility of yours. You need to check the design. You need to coordinate the mechanical shafts locations comes from the mechanical designer. That's why it's really helpful for you to execute a good design, a convenient and suitable design from smoke exhaust point of view. And also we have pressure, as we talked, we have pressurization system for the staircases in the high-rise building. The recommended design is to locate the pressurization fan at the outside of the building. That's the best practice. But you can not always be free to find some terrace on the top of these buildings. That's why you may locate these pressurization fans within the building. In that case, you have to provide 2-hour fire-rated fan rooms that is taking the fresh air directly from the outside of the building. Because just for your information, the pressurization shaft is considered as a part of the staircase. When we design a staircase, the design criteria is exactly the same for the pressurization shaft as well. That's why it's really important for us. The pressurization shaft shall be designed and shall be constructed very carefully, because any deficiency that can be occurred within the pressurization shaft will block the fire escape stair, and the people cannot evacuate the building because of this deficiency. The pressurization shaft is required when the staircase exceeds 51.5 meters. If the staircase exceeds 54.5 meters, at least we have to provide pressurization air for every 3 floors at maximum. It means in every 3 floor, we have to have a grill that gives us fresh air from the pressurization shafts. But for the high-rise buildings, we are always preferring to have a grill in every floor, because it becomes more easier, because if you put grills for every floor, the grill sectional area will become more less than having pressurization grills for every 3 stories. You see here we have a shaft neighboring the staircase, and we have grills into the staircase for the pressurization air. Just for your information, the pressurization shaft cannot be separated from the staircase. It means the pressurization shaft shall be located just next to the staircase, because it is considered as a part of the staircase. For example, it is this kind of, we have a pressurization shaft here, we have a stair well. Sometimes they are trying to link them with the hard duct system, canal. It is not allowed, just for your information. When you have a staircase which needs to be pressurized, this pressurization shaft shall be neighboring to the staircase. It's very important. It changes all the design. No one can accept this kind of separation. That's why they will require to redesign your building according to the fire code requirements. As you can see, we have a fire escape staircase here, and we have a pressurization just neighboring the stairwell, and the grills will have between the pressurization shaft and the staircase. And also the fire service escape stairwells are pressurized. When you have a fire service access elevator within the building, you need to provide a pressurization shaft for this elevator well as well. If you forget to provide it, they will require you a hard duct system at the corner of the elevator well, and it is not accepted by the elevator, the guys who check the elevator and approve the elevator. Inspectors, yes, Sağ olun hocam. Inspectors are not accepting this kind of hard ducted system. That's why having a pressurization shaft just next to the service access elevator well is really important and should be designed from the beginning of the project. And also the important thing is really important, because the wrong design system can cause some problems during the handover stage. If you have a pressurization shaft, the net area shall be not less than 1.1 square meter. It comes from the performance and functional test of the pressurization system conducted on site. This is not a written rule, but our inspections show that the shaft area shall be not less than 1.1 square meter. Otherwise, the velocity of the air increased, and that caused higher pressure loss, and the pressurization system will not work as required. We cannot see the required pressure difference between the staircases and the lobby. That's why the area should be not less than 1.1 square meter. And the aspect ratio, it means the ratio between the length and the width of the shaft should be not more than 1.4. It means if you have a dimension of A here, it should be a maximum of 4A. Otherwise, this shaft does not working due to the same cause. Having an aspect ratio more than 1 to 4 cause higher pressure loss, and all of the design is changed accordingly. For example, you can see an inconvenient shaft here because the aspect ratio exceeds 1 1 to 4. That's why that will not work as required. And here you can see a convenient shaft arrangement. The aspect ratio is okay, and the required shaft area is fulfilled. It will work as required. As architects, we need to check the shaft dimensions, we need to check the aspect ratio, and we need to be sure that it has a required sectional area. Otherwise, the system will not work during the handover stage, and they will ask you to revise the shaft, which is not possible for the completed construction. And also, as the last issue, if we have a car park, and we always have a car park for the high-rise building within the downtown of the cities for sure, we need to provide a smoke exhaust system as well. For the open car parks, the smoke exhaust system is not required, but to consider a car park as an open car park, there should be at least 5% of the sectional area of each floor on the facade. For example, if you have a floor with 100 square meter, there should be 2.5 square meter opening on opposite facades of the building. It is not possible for the basement floor car parks, but if you are designing a car park for the airport terminal building, for example, the car park of the new Istanbul airport is considered open car park, and we don't have a sprinkler system and we don't have a smoke control. But it's really difficult for enclosed car park located beneath the buildings on the basement floor. And if you have an enclosed car park system, you have two options. First of all is conventional hard ducted smoke exhaust system. And the second option is a jet fan smoke exhaust system. Both of them has these advantages and disadvantages, but I will try to explain you the main differences between each of them. For the hard ducted system, you will have these kind of ducts all around your car park to exhaust the smoke and exhaust air released from the cars. And it causes you a drop on the clear ceiling height. For the car park areas, you have a clear ceiling height, and since if you provide a hard ducted system, you need to add the height of this duct onto the floor, and it ends up with higher floors, higher ceilings, and it ends up with have a less number of basement floors. That's why the optimization between the required clear heads and the required number of basement floor should be done by architects to decide which system will be used. And the second one is the jet fan system. The advantage of jet fan system that is you don't have any hard duct. That means you are more flexible for the clear height of each floor. But for this system, you need to have large fresh air, and also the exhaust shafts for the taking fresh air from outside of the building, and also to extract the smoke from the car park. Also for this system, the architect is responsible for the determination of the makeup air and exhaust air shafts. If you choose them, if you locate these shafts very close to each other, then you will face with some bypass and you cannot extract the smoke from the enclosed car park area. That's why you need to coordinate. You need to coordinate with the mechanical designer for the shaft locations, and you need to describe shafts as far as possible to each other, so that the fresh air can be moved by jet fans and the smoke will be sent to the exhaust shafts and to be extracted from building to the outside. That's why the shaft locations shall be studied from the beginning of the project, because when you start to pour the concrete for the basement floors, to open a new shaft will be very impossible for the structural guy and also for the construction team. And for approximately for each 2,000 to 3,000 square meter of car park, you will have separate fresh air and smoke exhaust shafts, and these requirements will be given by mechanical designer to you, but you need to have a minimum level of knowledge to understand and to evaluate the requirement of the mechanical engineer, because you have to optimize the number of shafts and the location of shafts. If you don't know anything, the mechanical designer will require from you a maximum number of maximum number of shafts to stay in the safety side of the design. But if you know that, you can discuss with them and you can optimize the design as well. And you can see the true shaft locations here. They are located in opposite walls, so that when the fire incident is occurred, the jet fans take the fresh air from one side and they are throwing to the smoke to the other side, and they are extracted to the outside of the building by axial fans located within the shafts. And it's all from my side to you for the architects regarding the mechanical design. Since we have we are making this lesson in a special day, I would like to provide a quote of Atatürk regarding the knowledge and regarding the good level of knowledge for your how to say for your responsibilities. I hope it was a good and informative lesson for you guys.